Introduction L2 Regularization. Linear regression shows the linear relationship between the independent variable and the dependent variable. Here is the code snippet of the linear regression. The fitted line plot shows an overfit model. In the graph, it appears the model explains a good proportion to the dependent variable variance. How to avoid overfitting in regression? Actually, regularization is a technique to discourage the complexity of the model. It does this by penalizing the loss function. This helps to solve the overfitting problem. So, we are using ridge regression as mentioned in the task. A regression model that uses L2 regularization technique is called ridge regression. Ridge regression adds square magnitude of coefficient as penalty term to the loss function, and it is the loss function here. Ridge regression taking a different approach. Instead of using the absolute values of coefficient, it adds a penalty term proportional to the square values of the coefficient. This has the effect of reducing the magnitude of a coefficient but doesn't force anything to become exactly zero. Here is the mathematical representation of the L2 regularization. The importance of lambda parameter in overfitting. Actually, lambda controls the strength of the penalty. When lambda is 0, ridge regression becomes an ordinary linear regression. As lambda increases, the penalty on the coefficient also increases, and the values of the coefficient decreases towards 0. This can reduce overfitting as the model becomes less complex. Therefore, the choice of lambda is a balancing act. It should be large enough to regularize the effect of the predicted variables, but not so large that the model loses its predicted accuracy. So, cross-validation is often employed to tune these hyperparameters, allowing us to strike the right balance between the model complexity and overfitting. In conclusion, regularization technique like L1 and L2 help preventing overfitting by imposing constraint on the model's coefficient, ultimately leading to more robust and generalizable regression model.